Hello and welcome to Gurobi Day's Digital Academic. Thank you for joining our session today, where we're going to be covering our open educational resources that we've been developing over the last 2 years and released for our users and learners new to optimization. I'm Lindsay Montanari, and I lead the academic program at Gurobi Optimization. My role here is focused on expanding our university partnerships and working with experts and thought leaders to build out new resources for both faculty and students to teach and learn optimization and Gurobi. Since our founding in 2008, Gurobi has been fully free for academics to use, and we have quite a large user community, including students, faculty, and researchers. Last year alone, we had over 150,000 academic license installations. And today I'm going to be walking you through how to access some of the free resources available to the academic community and some of our introductory resources as well. So very quickly, if you visit our website, which is the main place that you can find all the resources available to academia, and go to the academic section at the header, you can scroll down and find the license types available to academics. Our most popular is the academic name user license, and you can find details on how to register, access, and download that license right here. The next thing I wanted to talk about is a little bit about how we have been developing new introductory materials for learners. And truly, the what is optimization? How do we explain optimization, and how do new learners start their path to understanding optimization and to working with Gurobi? So I'm going to highlight a few of the tools that are new and have been released over the last couple of years. First, I'm going to talk about an exciting game that was developed by our team here internally. We were working with an external faculty member named Dr. Larry Snyder from Lehigh University to gamify optimization and demonstrate the power of optimization to new learners. I'm going to quickly show you how to access that game. And the game is a full resource for both instructors to use in a classroom. We have supplementary materials, including slides and also lesson plans that instructors can use, or how to use it as a learner on your journey in optimization and learning optimization. So if you go to our website one more time and you visit the academic section, hover over it, on the right, you'll see the burrito optimization game. When you click through, you hit the landing game, www.burritooptimizationgame.com. You can look for the game guide, the teaching guide, or you can dive right into either playing the game or registering to play the game. If you're not a Gurobi user already, you're going to want to hit that registration link first. And once you're done and you set a password and you're verified, you dive right into gameplay. So it's very easy to find, and all the supplementary tools as well can be found on that same landing page. So we hope that you take a look at it and explore a little bit about what that tool can do and how it can be leveraged within the classroom or within a training setting. The second thing I wanted to touch on is our optimization demos. These demos illustrate the value of mathematical optimization. Each demo is essentially a proof of concept of an application that addresses a challenging and high-value problem in a particular industry. These demos give you the context to understand the problem that you're solving before you dive into the model and work. You'll also see how the applications can be implemented within a modern IT architecture deployed on AWS using Gurobi Cloud. You can find a range of demos tackling problems like offshore wind farming, the traveling salesperson problem, workforce scheduling, and so many more. So be sure to check that out. Again, you'll need to be logged into your Gurobi account on the website to access these demos. The next thing I wanted to chat about is the dozens of case studies available where academics can find a range of real-world problems that Gurobi is solving across industries. Our case studies cover everything from sports organizations to major airlines to global tech companies and to rideshare services. These case studies offer an overview into real-world problem statements and solutions and include problems like the NFL scheduling their full football season. Here's a range of the case studies that we've got available for new learners to explore. On the top of that slide, you can see we've had many that we shared last year, even at this event, and we've added quite a few new ones. So SAP is new this year, ESUPS, which is ESUPS, part of Welthungerhilfe, doing emergency stroke prepositioning, J-Power, and so many more. So be sure to take a look. There's a QR code from this slide where you can access those case studies and explore a little bit further. And then the last thing I wanted to highlight is that we have a full academic community YouTube channel, which is a quick guide, quick set of tutorials on how to do everything from license installation to some of our most frequently asked questions. I'll walk you through where you can find those videos in our YouTube channel. So again, if you start your journey by going to our website and hovering over academic, click through on academic and scroll down just a little bit on this page. And you'll see the Get Started with Gurobi Optimization section. Here, you'll see a few different options to get started, but if you click Join the Community and Academic Community Channel, you'll link right through to our YouTube channel. As I mentioned, we've got installation guides for different OSs, we've got frequently asked questions, and we also have some of our webinars that we've showcased exclusively for the academic audience over the last year. So great resource to get started and get quick overviews of how to get started with your license, how to download your license, and also some of the tools that we've released to the academic community in a little bit of a deeper dive than you're going to get in this session. So the next thing I wanted to touch on was another game in addition to the burrito optimization game that we released, and it's called the Gurobi Pi card game. We introduced this to help students learn the basic building blocks needed for optimization modeling with Gurobi in Python. It's an actual card deck, and we've got a full PDF version of that card deck. So if you click through on gurobi.com card game, you will find the resource that allows you to download a PDF, cut out versions of the card, and go through two different games, one a little bit more of an entry point and one a little bit more advanced. And then the last thing I wanted to touch on is if you prefer longer format videos or trainings, we have a series of tutorials that we created to help academic users and students get started with both linear programming and mixed integer programming. These videos are about 15 minutes long, and they walk academic users through mathematical programming in a sequential and an applied way. So you can take a look at some of the videos that we've got, and these tutorials are listed on the left there. We've got a QR code that takes you right to that page. So again, this is a what is optimization overview and some of the entry points and introductory material that we've put out that we hope that you find useful in the classroom and in your learning journey. Thanks so much.
Hi, I'm Cara Touretzsky, and I'm a technical account manager here at Gurobi. And part of what I do as a technical account manager is to help new users get started using our solver. And we have a lot of resources to help you create and implement your optimization models. So I'm going to review some of the different ways you can use Gurobi and some of our modeling resources that are available to you. So one of the first things you'll think about when starting a new project is what language or what platform are you going to use to build your model? And so you can use the Gurobi API with any of the 7 most popular programming languages that I'm showing here. I do encounter a lot of Java and C#, but Python is definitely our most popular. And that's especially true in the academic space. And one of the main benefits of our Python API is we also have several open source packages, and these can really enhance your modeling experience. And so I've got a few of those listed here on the slide, starting with our Gurobi Pi Pandas package, which lets you read in data from a Pandas data frame. And we also have our machine learning package, which lets you actually embed a trained predictor into your set of optimization constraints. So those are 2 really popular packages that came out last year. We also have the GRB log tools package, and this is great because it can help you visualize the content of our log files. And we also have the newly released OptiMods, and we'll talk about that a bit more on the next slides. So in addition to our native APIs, notice I've also got 2 boxes on the slide showing modeling packages. And so these are generic modeling languages that have the benefit of letting you actually change the solver without having to rewrite your model. And so the commercial modeling packages like AMPLE and GAMS and AIMS do have academic licenses, and you should definitely check out their websites to get access to those. But there are also some open source modeling languages like Pyomo, Google OR tools, CVXPy, and Pulp, which comes from the CoinOR project list. And these are also freely available because they're open source. One thing to be aware of, though, if you do use these packages, is that they may not give you access to 100% of Gurobi's features. And sometimes the model build times can be different using a package like this versus our native APIs. But so when you're starting to build your model, going through this choice of languages and what packages you're going to take advantage of is the starting point. And we have documentation for all of the native APIs on our website. So once you've picked your language, now it's this question of how do you actually implement your model, right? How do you write your model? And writing a model from scratch is often a lot of work. And so to help with that, we have a few different ways that you can leverage examples or notebooks on our website to give you a head start. And one of the first things we're going to look at are our functional API examples. And so I'm going to actually show where the link in here takes you on our website. So here's a list of our basic examples, and these are very short and condensed examples that show you exactly how certain functions or aspects of our API work. And these are great because for each example, you could see it in whichever language you're using. So if you wanted to know how to write a SOS constraint, you can look at that in the language that you're used to working with. As a next level of complexity, I'd say we have our Jupyter notebooks. And so these are more advanced examples. We have about 40 of them on our website for both operations research and data science applications. And these are really nice because you'll be able to see the model, but also how we translate that model into code. And so I'm going to switch back to that section of our website. So if I open the first one on in the list here, which is about agricultural pricing, we'll be able to open the notebook, give it a second to load. Here we go. And so you can see we give the problem objective, the problem description, the actual mathematical model formulation, and then finally the Python implementation. And so if you're working on a certain model and you know it's similar to one of the applications we already have in this library, you can use that as a starting point for customizing it to your use case. Okay, and last we have the OptiMods. So this is a new open source Python library that we've just released. And here you have a selection of different OptiMods or OptiModels that you can pull from. And really, it lets you start using the model quickly, and you can just focus on the data input-output, but get the results from the model for your application right away. And so I'll just show you the documentation for this really quick. Here's the gallery. And so these are the mods that we've already implemented. We just had a webinar on the optimal power flow model. But here you can pick your mod or model and focus on the data I/O without having to customize the model to your use case. So the benefit here is what I would call like a low-code implementation. It's a way to focus on the use case and the data, but not so much the model. So depending on what you're working on, whether you're writing a model from scratch or you want to just focus on the results, all of these examples will let you do that. So the last thing I want to touch on now is after you've picked your language, you've implemented your model, but how exactly are you going to run it? And this is where licensing comes into play. So just very quickly, most people in the academic use space are going to be able to get most of what they need out of Gurobi with our named user license. This is a license that's just for you. You can install it on your laptop or your desktop, wherever you're used to working. And this is the most common license that we extend in the academic space. Now, if your university has a site license, or if you're a university administrator and you're interested in getting one, that's another great option to enable a wide number of users under a single license. We also have the academic WLS license, and this is really meant for students who are going to be working with Gurobi in a containerized application. So unless if you're using Docker, then you would want to use the WLS license, but if not, then the standard named user license is going to be what you want to request from our website. And if you have any more questions on that, the link is here to get to our academic program licenses, and you'll be able to request those and get access as needed. So thank you. If you have any other questions, please go to this website link and you can reach out to our support team.
Hi, I'm Alison Cozad. I'm part of the Gurobi expert team, and we help customers and users like yourself use Gurobi better. So let's say you're at the state where you've determined what optimization is, you've determined why it's useful, and alas, why it can be a little bit difficult sometimes. And you've taken the further step to say that maybe you've created your first model or maybe your first few models. Your next step is maybe, how do I improve my optimization? Or possibly, how do I improve my optimization skill set or my optimization model? In the next slide, we're going to take a look at educational resources that really help you learn the nuances, strategies, and advanced technologies for kind of upping your optimization skill set, really helping you better leverage the cutting edge capabilities within Gurobi and the most recent enhancements. Okay, your first tool that you're going to have is our Gurobi webinars and videos. So if you haven't signed up for our email list to get on our upcoming webinars, please do. Otherwise, we have a lot of them that are already available on our YouTube page. In that tiny little circle that you see on the screen, there's a pretty cool tech talk that we had over the winter holidays about some really nasty but interesting problems that were kind of head scratchers for us too. And you know, that really walks you through how did we solve the numerics or the problem to really kind of take it to that next step and address the issue there. And things like this, along with case studies and advanced techniques and tunings, are all really what these webinars are all about. But if you do want maybe more kind of one-on-one guidance and help, we do have in our next slot the Gurobi support team, which is the Gurobi experts like me, where we have PhD level specialists that are really excited about helping you be helpful with or be successful with optimization. And for our commercial customers, we have comprehensive support, including answering licensing and installation questions, really helping you improve your Gurobi performance and API usage, helping provide some insights into the trickier solver behavior that you might not understand, and really offering implementation tips for faster model building or solve times. For academic users, we're here to make sure that you can get up and running with your licenses and installation. I have a link on the slide to help you see what's in scope for academic support as well. And what's available for both our academic and commercial users is our self-service. So if we head to the right side of the slide, we have our Gurobi knowledge base. And so these are articles based on questions that we get all the time. So we've written these up, and so they're tips and FAQs and kind of how to solve common issues. I'll actually pull up an example of this here. So if you go to support.gurobi.com, that's where you're going to find our knowledge base. And let's say you were like me when I was first trying to start or kind of take my next step in modeling and trying to figure out, how do I take my if-then or my conditional statements and make them into an actual algebraic model? Well, we have the KB for you. We have the knowledge base article for you. So you can click on something like this and take a look. So my colleague Yarick wrote up this article that really helps you walk through taking, if X is greater than or equal or greater than Y, then, this might be true, or else something else might be true. It walks you through how to write the big M constraints that you might need to actually take this if-then logic and put it into a math model. And also goes and shows you that there's other alternatives that maybe are more numerically stable, like indicator constraints. and then gives you the sample code to get started with that. And this is just one example of a knowledge base FAQ that you guys can dig into and take a look at. This happens to be one that's fairly popular, so that's why I brought it up. But if you do have questions about maybe your specific problems, we also have the Gurobi community. I like to think of this as the Stack Overflow for Gurobi. But this is really chatting with fellow optimization enthusiasts and asking questions or responding to posts on there. So you can click on the link here, but I'll once again pull up an example. And so if we scroll up and head over to the community, we can maybe again look up conditional statements. All right, if we hop on the second article or the second community post. So we had a question from a user that was really trying to understand, how do I put in this conditional statement, this specific conditional statement into my model? My colleague Eli actually went through and started explaining what an indicator constraint is, explained how to actually write that in math terminology, and then goes through and actually shows how to do it then in Gurobi Pi. So this is another way to get your questions answered if you're really trying to take yourself to that next step of understanding how to do your optimization better.
Hi, everyone. I'm Jerry Yurchisin, data science strategist for Gurobi Optimization, and I'm going to dive into a little bit how you can add machine learning to your optimization models by diving into some new tools, examples, and other fun things that Gurobi has put together over the last couple of years. So when you're asking, hey, how do I add machine learning to my optimization models? One of the important questions that you should ask a little bit before that is why combining machine learning and optimization is even important in the first place. So we're going to tackle that question, and then we're going to get into how you can learn and teach the combination of machine learning and mathematical optimization using a bunch of resources from Gurobi. And to answer that question, to see how we can do that, we're going to dive a little bit into a set of data science notebook examples that we've put together over the last couple of years. And I'm super excited to also dive into some Gurobi sponsored open source packages that we've recently released. One of which shows how you can take trained machine learning models and embed them directly into a larger optimization model. And if that seems a little too much for you right now, then the other open source package that we have allows you to use pre-built common optimization models sort of as a black box, so you can use optimization without even really knowing that you're using it. So the first question that I asked was, hey, why is it even important to talk about data science and optimization together in the first place? Well, you see this graphic I have on the left, and there's a lot going on there, so I'll quickly go through it. On the horizontal axis is a median salary for a certain job, and the vertical axis is how much that job is expected to grow or not grow over the next 10 years using data from the Bureau of Labor Statistics. And the size of the dot is sort of proportional to the size of the number of people in that job currently. So there's a lot happening there. And also the color of the dots represents sort of the a broad range of industries. So health or computer and math or production, things like that. So I'm going to zoom in a little bit and sort of that boxed area, blow that up a little bit, and sort of focus on some of the orange dots that you sort of see on the right. You see data science. Awesome, very high median salary, very nice job growth, all of that stuff. But right below it is operations research analyst, which is something that some people sort of consider that job as a little outdated or not as in demand right now. But per this this data and sort of updated versions of it, we see that that's definitely not the case. So the main point is that operations research and data science are both very popular, both very in-demand skill sets. And specifically for OR analysts, they're expected to grow over the next 10 years from 2021 to 2031 by 23%. So that's definitely a nice career path to choose if you're going to go down that road. But what I would say is the best way to go is, hey, both of these things are growing. Both of them are in demand. Make sure that you have skill sets in both. So how do you combine machine learning and optimization? Well, it's sort of how you do that fits into three main buckets. And one is, at the core of every machine learning algorithm is actually an optimization algorithm. There's actually optimization going on behind the scenes. So even something as simple as least squares is a minimization problem. And that happens throughout a whole bunch of different types of machine learning algorithms. So a lot of things like XGBoost and all of these sort of fun algorithms that you use sort of without even really understanding or really checking out what's under the hood, a lot of that is an optimization problem in the back. Second is the sort of the most common way that we sort of combine machine learning and optimization, and that is to use machine learning to build some sort of forecast or to understand some relationship or to come up with some numerical prediction and use that numerical prediction in an optimization model. So you may build a machine learning model to understand future demand of products or inventory levels, come up with some numerical values, and use that as a parameter in optimization. The last way that we can combine machine learning and optimization is take number one and sort of flip it around. And that's taking the machine learning algorithm and sort of embedding it into a larger optimization algorithm. And this is something I'm super excited about and really glad we get to sort of talk about it today. So imagine that you have a price-demand relationship for a product or a certain set of products. Obviously, as price goes up, demand will go down, and vice versa, but understanding that relationship and accurately predicting that using a wide range of features is a very, very sort of intricate and complex machine learning model. So if you were to take that and say, okay, well, now I understand that relationship, I want to maximize my revenue subject to some other constraints and other things that need to happen, that gets very complex. So you need something to help you sort of build that take that relationship and put it into an optimization model. And that's what one of the packages I'm going to describe. That's exactly what it does. So I'm super excited to dive into that in a little bit. So first, what I want to talk about in terms of the resources that are available for you to learn optimization and to teach it through a data science perspective is our notebook library. And I'm going to talk about it in general and then dive into the data science part in a second. But in general, we have a large number of examples that range from very introductory, sort of the bare basics, the bare bones of optimization, to super advanced stuff that really tests even the most expert optimization modelers. So no matter where you are in your journey to become an optimization sort of expert, or even anywhere in between, you'll have something that'll challenge you. We use our Python API for these examples because they're all sort of like Jupyter notebooks and such. And being able to use our Python API allows us to use key Gurobi features and also the open source packages that I'm going to talk about in a little bit. And Python is by far the most popular data science and data analytics language. So, any sort of work streams that you have or any other examples, any other, the connecting the predictive to the prescriptive is really easy using Python. We have numerous industries and topics. So no matter what you're interested in or what your students are interested in, what your topics are in class, you're going to have an example that should be relevant. And what's great about notebook examples is it gives learners the freedom to experiment without having to worry about breaking anything. You sort of just rerun a previous cell and you're back at it. So it's a great way to sort of learn, to test stuff out, to see, hey, I think this is how I would add this constraint or something along those lines, see if it works. And if it doesn't, you're not really breaking anything. You don't have to start from scratch. And this may help you find inspiration for your coursework or your projects within your classes. So to dive into a little bit more of the specifically what we have from a data science perspective of how we combine data science and optimization, here are a few of the examples that we've put together. One is a fantasy basketball example where we use historical box score data to build a very simple optimization model. And then in part 2, we expand that a little bit. Price optimization, we have an example that is probably our most popular amongst this set, and actually one of our most popular examples amongst all of our notebook examples. And it uses first a simple linear regression model to model price and demand, but then we also in a second version use the package that I'm going to talk about later. So it's definitely a good one to dive into. But in addition to that, we also have a more intricate music recommendation system. We talk about renewable scheduling, airline disruption, which is a super hot topic as of late. And then also a text similarity example, which is something that you wouldn't think that linear programming or mixed integer programming is even really suitable for, but we sort of show that, yeah, it is. And then our full library has, again, a bunch of different topics, bunch of different industries, things like more energy examples, healthcare, airlines, telecom, anything that you're interested in or your students are interested in, we have something for you. So the first thing I want to talk about from the open source perspective is a package that we've released that we hope a lot of people contribute to called Gurobi Machine Learning. So it's open source Python package that allows you to embed those trained regression models like I was describing before. But here's what's really interesting about this package as opposed to maybe some other things that you see. Regardless of if you use an sklearn, XGBoost, PyTorch, Keras, all of those, it's still one package and it's still just a couple lines of the same couple lines of code to use any of those types of models. So it's a really easy way, because we know that during testing or even after you test and you're sort of putting things into more of a production environment, you still use different types of models. So this allows you to easily update that without having to use different packages and different things like that, using different syntax. It's just your one-stop shop for essentially embedding these machine learning models into optimization. I think this is going to be something that's super popular. So definitely take the time to look at our documentation. We also have a webinar. And like I said, we have a notebook example. All of those links will be provided to you. So the next thing I want to talk about is our other open source package that I'm really excited about called Gurobi Optimods. And this is a repository for sort of already implemented optimization use cases. So these are common optimization models that you can use however you need to in your learning or your course. So the typical flow for one of these OptiMods is you take a set of input data, which is sort of in a very intuitive shape and form, and also from a structure perspective is either something like a pandas series or data frame or NumPy. So it's things that you're already used to working with. And then in the next set, you take that you sort of essentially just feed that in a functional form to an OptiMod. And I put the color of the arrow of the OptiMod from black to white on purpose, because it could be as black box as you like. You just give it the input data, you look at the output data, and that's it. But if you're interested in what's going on under the hood, the code is there, the documentation is there for you to really understand what the model is doing. So as much detail as you want is what you can get. And then the output data is very intuitive. It's of a form that makes sense for the problem. And it also, if you put in pandas in, you're going to get pandas out. And then lastly, these OptiMods are also going to give you relevant metrics. So I'm going to, in a minute, dive into the maximum Sharpe ratio OptiMod. And part of that is, not just, hey, what is my optimal portfolio to maximize this metric, but what are other relevant metrics? Like what is the actual estimated return? What is the risk? And what is the Sharpe ratio itself? All of those things are reported back. And that's true of any of the OptiMods. So let's dive into that OptiMod right now. All right, let's dive into this Sharpe ratio OptiMod. So again, the goal of this OptiMod is to give you the optimal weighting over a set of potential stocks that you want to invest in that maximizes the Sharpe ratio. So we're trying to find what percentage of each individual stock should we use, should we invest in order to maximize that ratio. So I've already installed the Gurobi Optimods, and then we're also going to use a little bit of data from a Yahoo Finance package. What I would suggest as a good first step for each of these OptiMods is to take a look at the example data sets. So that'll give you a very good, and this is also in the documentation, but it'll give you a very good sense of the structure of the data that you need in order to use the OptiMod. So let's take a quick look at that. I imported the data sets and let's print them out. So there's two main pieces of data here that we need for this OptiMod here. One is data.mu, which is the expected returns we see here. And then next is the covariance matrix, which we see down here. So essentially, any type of data that we want to use for this, it should be in this similar format. But also keep in mind that it can take various types. So it can take pandas, data frames in series, and also NumPy arrays. So next, instead of using this simple data that we sort of see here, let's sort of make things a little bit more complicated by downloading a year's worth of data of this set of stocks. Let's take a look at that. So quick and easy. What we're going to do is we're going to take the close price for each day and for each of these stocks, calculate the percent change, and then use that to estimate the expected return just by taking the mean of that. Here's where you as a data scientist or your students as data scientists should build a much more robust, much more detailed predictive model than this here. But essentially, in the end, we're just worried about the same output. We just want the expected returns. So let's calculate that and take a quick look at what that yields here. So this is the expected returns for our set of stocks. So now let's actually fire this thing up. And essentially all you need again is that covariance matrix and that set of expected returns. Feed that into this function here. And that is literally it. You can make this again as black box as you'd like if you'd want to understand more about the formulation and everything and learn how what the optimization model is doing. Check out the documentation. That's pretty thorough there. If you just need to use this again as a black box function, feel free. So this is again a great way to sort of introduce optimization modeling without having to understand anything that's happening happening under the hood. So we have our optimal, we reached optimality here. So we may be interested in a few things. One is, well, what is the optimal weighting? And also, like, what types of things can we get from this OptiMod? So if we just look at sort of some of the suffixes that we can look at here, one is RET for return. So this is how we can extract the return of our our optimal portfolio. We can also look at the risk and the Sharpe ratio, and then X is the actual weighting. It is the optimal solution of our decision variables, which again is how do we distribute our investment percentage wise. So let's look at that. And this isn't a great thing to look at. It's a lot of E's negative. This is essentially 0. These are essentially 0. There's only a few of these things that are actually worth looking at. So let's look at the columns for the ones that are pretty much that are non-zero. This tells us the which stocks we're going to invest in. This is telling us what, in a more concise form, what our distribution is. And then we can look at what the Sharpe ratio is, and again, look at the return, look at the risk as well. So there's a bunch of bits of information that we can look at in order to analyze the solution a little bit further. So this was great so far. if you look at the documentation, there is also a section about how to use simulation to see if you can get an optimal, portfolio by randomly assigning weights and seeing what you get and how many sort of runs of that simulation you need to get to optimal, or you probably wouldn't get it, but get near optimal. Take a look at that. And here's my exercise to you, is to take that documentation, what's in the, again, that code is in the documentation, take that, adapt it to this example. So sort of mimic this and see what you get. You might be surprised with the difference between running this as a pure optimization and seeing what simulation would do, and what that gap may be. So that's my homework assignment to you. So now we're going to head back to the presentation to look over a couple more slides before we head out. So I hope diving into that OptiMod and showing how easy it is to use these and so you can sort of see like how detailed you can get, sort of how easy it is to pick up and use. I hope that came through in that brief little demo. So what I want to talk about now are a few things that are coming, sort of down the road to help you understand from, if you're a data scientist, hey, what can I do to learn optimization? Later on this year, we're going to have Optimization 201 for data scientists, which will be 2 partial days of hands-on training. If you're thinking, well, you're already at 201, where was 101? We did that late last year. It was an exceptionally fun time. I had a blast doing it. So keep tuned with us, and we're going to re-release the 101 material, so you'll be able to catch up before you get to 201. So a quick summary of everything that I sort of went through really fast is, in order to prepare for future success for yourself or your students, having an understanding of data science is super important, but also an understanding of mathematical optimization, and because we see that both of those skill sets are super in demand. Gurobi is committed to year in and year out creating new learning resources that we're going to keep putting out to help you reach a diverse crowd. So again, if you're a data scientist, business intelligence person, or an OR expert, there's going to be something that is going to be interesting for you and help you along your optimization journey. And we're always looking how to reduce the barrier of optimization, because we understand that can be a limiting factor for some folks. So through things like the machine learning package, through OptiMods and trainings and other resources, we're always trying to get optimization into the hands of more folks. So I hope you enjoyed my quick little talk. If you have any questions, feel free to reach out, and I hope you dive into all of this great stuff that we put together. Thank you very much.